All right. So if you may not know Ciena, our contributions in here, think of us, we're the company that developed commercial WDM and commercial coherent detection. And you put those two things together, that's the technologies that have let us take network cores from gigabits to terabits. And so the great thing about being an optical company, it's the foundation for the network. We see everything. We see all the traffic. We see the traffic growth. We see where it's coming, where it's going. And I don't think I've had a conversation with a customer, a partner, a supplier in the last probably 2 or 3 years that didn't touch on AR, VR, XR, or Metaverse. And so what I've tried to do is just abstract it up to a very high level, because almost all those conversations come into one of two categories. I've tried to capture it on here. So on the left-hand side, what have you got? All your different access technologies, right? Enterprise, residential, wireless. And I'll be the first to admit, inside of every one of those boxes is probably starting on a wireless connection of some kind. Could be Wi-Fi, could be a AR, VR headset that's sitting here with millimeter wave gigabits flowing to a local processor, right? So I'm fully aware we're starting on a wireless environment. We want to get to the cloud. So there's really two questions about it. One is, how far can the cloud be from you, right? Because there's some real physics here. Things have to get out there and get back, right? So that's just physics of propagation. And then how big does that thing have to be? I don't mean necessarily directly to the headset, but what carriers worry about is, what's my infrastructure going to look like? How big of a metro infrastructure, front haul, back haul? I mean, what sizes do I need to have here? Because the great thing is today, every time you put a fiber in the ground, potentially it's terabits if you want it to be. There's great economic reasons we don't light them that way today. We still are in the gigabit region out at the edge typically. But that's the fundamental questions that we have to answer for our customers when they build out the infrastructure, because they're not going to get to do this 5 times in the next 10 years. They're going to get to do it once in the next 10 years. So they want to get it right. So what I've tried to do on here is capture all the different applications people talk about. And I put 2 axes on here, latency across the bottom and bandwidth going up the y-axis. And I'm going to call it mean time to cloud. And again, that is from whatever the smart device is at the edge of the network. Your handset, your laptop, your tablet, your crypto miner, whatever you got, right? You have some expectation of user experience out and back to the cloud. I put a whole bunch of different things on here: factories, residences, robots, vehicles, all the different applications people talk about. And there's a number on there I threw up, which is 10 milliseconds. Now, 10 milliseconds is really interesting for a whole bunch of reasons. One of which is, if you talk to the medical community, the guys that do a lot of intensity gaming and such, you get latency under 10 milliseconds. And all of a sudden, even the most sensitive people to motion sickness don't feel it. They don't sense it anymore. So it's kind of a nice round number. Now, reality is at 12 or 15 or 9. Nobody really knows for sure, but 10 is a really nice number. The other reason it's nice is on fiber, just time of flight, just photons going from A to B and back, that's 1,000 kilometers. So right off, because we know network latencies are much larger than that, it's not time of flight on the fiber. It's not distance that's done this to us. It's the way we've built the metro networks. If I plot on there all of the different kinds of applications, that's the red line about what networks can do today. If I work really, really hard, yeah, I can get sub 10 millisecond networks. But most of them are going to be up tens of milliseconds at the hundreds of milliseconds. And even if they're low latency today, they're going to have variance. Unfortunately, I can give you more examples of people trying to move things to the cloud that worked 99% of the time or 99.9% of the time. But that 1% where it failed, or that 0.1% where it failed, frustrated the application and they couldn't use it. And so they stayed with local servers. They couldn't push it into the cloud. Even simple things like point of sale went that way, right? Because latency today in most networks is not a governed quantity, and it certainly doesn't show up in many SLAs. If you look at things like Internet of Things, if I'm sitting there in my residence, right? I leave, I forgot to close the garage door, I press a button, you close it, and a second later, you don't care. But if I'm on a factory floor and I'm closing to an autonomous robot, or I'm doing autonomous forklifts, or I'm really interacting with something, all of a sudden latency becomes very important to me. And if I start plotting through all those, what can I do in the future? You're going to need to move that line way over to the left, especially if we want to get into things like what has been termed tactile internet, or really immersive kinds of environments. Latency is going to become far more important. And so you say, okay, you said 1,000 kilometers, 10 milliseconds. How much of that total latency budget are you going to put to what classically is known as motion photon? How much of it is going to be in the air interfaces? How much is going to be in the front haul, in the back haul? The first time you go up and down the IP protocol stack, the second time you go up and down that stack, the third time you go up and down that stack. How about when you get into the cloud and you got to process it? And by the way, then you got to go all the way back, right? I haven't seen very many people go solve the whole problem. We're still solving incremental pieces of it. I think to really get AR, VR, XR, Metaverse to work as a community, we have to solve the larger problem, right? So this gives you a sense of just what's involved. So let's say, again, 1,000 kilometers. I'm going to give just 10% of that whole budget, that whole latency budget. I'm going to give that to the network, just time of flight. What does that tell me? Because that's kind of an interesting thing to know. That tells me the first instance of cloud had better be about 100 kilometers away from me, right? Because that starts to set kind of a generic geographic distance that says if I'm thinking of my first cloud instance, not everything, but the workload that is most sensitive to latency better be located maybe 100 kilometers away from me. And then all of a sudden you say, well, here I am. Let's start drawing latency circles. You can take an entire geography and break it down into where can things really be if I have to place latency sensitive workloads in certain locations. So this gives us a pretty good sense of distance, right? 100 kilometers or so, gigabits in typical class for capacity. Let's look at the last one here, which is, let's take today's kind of backhaul infrastructure. So this is data that comes right out of internet service providers. And you say, if I invest in technology, and I've got 10 gig technology, so 10 gig PON, 25 gig, 100 gig, because I'm invoking kind of, as soon as you get to these rates, optical is the place to be. How long do those things last? And we know there's kind of 3 general tiers of consumers out there, which you might call the gig tier, right? Just average users today. You're going to have a multi-gig tier, and then you're going to have the many gig tier, right? Because that's what this is going to enable. You're going to enable consumption, creation and consumption of vast amounts of data. That's what AR, VR, XR is going to do. We're going to move the cloud closer to people. We're going to increase data rates. So we can expect this is what's going to happen. And there are some guesses on here about how long those technologies will last. Right? If you look at the middle, which is probably where most people will end up and where most carriers, most infrastructure providers, that's where they'll make their money. How long will these various technologies last? That tells you, 10 gig that's going out today, 2033, if we're lucky. So why is there such interest in even higher rate PON technologies? Well, that'll get you out into 2036 or so for that mid-tier. Why is there interest in 100 gig PON technologies? That gets you even more future-proofing. So again, when you look at what's the opportunity in front of us, there's so much money now being spent on putting fiber infrastructure out there. And again, I'll remind everybody, you put a fiber in the ground. Technologically, we know how to light that thing to tens of terabits. Okay. Again, good economics why we don't do it today at the edge, but that's the kind of capability that we've enabled as soon as we put fiber in the ground and we get fiber connections.